this is Bob the Science Guy, and I wanted to do a follow-up on a video I recently released. It was a rather long video, almost 40 minutes, on Phuket word and perspective. I've got the full link to both videos in the description, but I wanted to make sure everybody got to see the end of that video. A key skill common in real science is that we look at things with a skeptical eye. One of the problems with flat earth science is that they tend to start with a conclusion and then try and manipulate their data to support that conclusion. I want to present an example of that being done and see if you can figure out how they're doing it before I show you. Now, there are actually two experiments that were targeted by this video by Phuket Word. The first was an attempted debunk of Miles Davis. He's already been spanked pretty hard on this, but I think he's trying it again. To recap that observation by Mr. Miles Davis, this is a bridge in Scotland. Davis is on a hill at 210 meters. The top of that bridge tower in front of you is 210 meters. Lining up the observation height of 210 meters and the bridge tower at 210 meters, we see the 400-meter hills in the background are actually below the level of the bridge tower. You can see the linked video below, but this is irrefutable proof of a curved Earth. This is Mount St. Helens here in the United States, and on the background on the left you can see Mount Rainier. The observation heights are listed. The height of Mount Rainier and the height of that side peak on Mount St. Helens are clearly noted. A distant object from a near object with an object in between, you have a situation very similar to a gun sight. You have a rear sight, a front sight, and your target. By looking through the rear sight and the front sight, you can get an idea of whether the target is above or below your line of sight. This concept of a front sight and a rear sight is the key to both these observations. Now I'm going to go ahead and let you watch Phuket Word's video on this. I want to see if you can find the shell game that he plays and the errors that he makes.
Here we've got three lighters. 1, 2, 3, they're all the same height, as we can see from this orthographic view. Now let's just imagine that these lighters are mountains. And we have our side-on view of these three mountains, which at the moment happen to be exactly the same height. And we know what happens when we change our perspective and we take, let's say, an approximately 45-degree angle view. This one is closest to us, so it appears bigger. This one's further away, so it appears smaller. And this one's even further away, so it appears even shorter. Now, one thing to point out at this stage is that the camera's eye level, meaning parallel to the flat surface, is level to about halfway up. So what we know about perspective, and can be proven every single time, is that anything that is above your eye level will appear to sink down towards eye level as it goes off into the distance. And every time we change our angle of view, our perspective, there are changes that occur in the apparent differences of height. Once again, we go back to this view, they all appear to be the same height. We go this way, and of course this one's very big now because it's very close, and this one's far away, so it seems smaller, and that one's even further away, so it seems even shorter. Yeah, and when we come around here like this, we can see a distinct difference. But when we lift the camera up and the camera's eye level is level with the top of the lighter or the imaginary mountain, then those mountains in the distance also appear to be the same height now. Below eye level, they appear to get shorter and shorter. This is being used as a way to claim that things in the distance appearing to get shorter are going down a curve. But sometimes what happens is someone says, well, that mountain in the distance is higher than the mountain in the foreground. Let's make this mountain, or lighter, higher than this one. Okay, oops, let's check that. All right, there we go. Okay, this one is at the same height, and this one is physically higher, and we can tell from this perspective. But as we go around and we change our perspective, ooh, look what happens. We know this one is physically higher than this one, but this one appears to be taller. So when someone shows you a view like this, with a short mountain in the foreground and a taller mountain in the background that appears to be shorter than this one, and then gives you a bunch of calculations, you know they are trying to deceive you.
Okay, so we're going to go through this experiment again with these AA batteries on my office table here. And I've got an insert there with an example from his video showing it's the exact same thing. So right here we've got the side view, 1, 2, 3. Each battery is exactly the same height, 1, 2, 3. Okay, here we've got a view of the batteries looking straight down the row from near the top. It also would be the same there about midway up, as you can see, and we've got the lighters from his video. Once again, everything lines right up, 1, 2, 3, everything looks just the same, and everything makes sense. Now we go to the critical observation. We've got our near battery, which is very short, is much taller apparently than the far battery, even though the far battery is physically taller. This is a very strong argument that the observation by Davis and Baldicats is only due to perspective. Now, how many of you spotted what he did? Now, if you're a flat earther looking to reaffirm your fantasy, you probably mirror this on your site. But we have to be a little more critical here. Well, the first obvious thing is that he is not drawing lines of perspective here. He's using the side view and showing the level of the top lighter and then the level of the far lighter. Notice that they are parallel to each other. There are no lines of perspective here. What's the other obvious thing that he did to try and trick you? Well, here's a hint. How many lighters are there? And how many did we start with? Weren't there originally 3 lighters? Let's see what happens when we put the third lighter back in and draw the lines of perspective. Here's our same view with the reference battery in the middle to allow us to draw an accurate line of perspective. Now, which one's the highest? You see, Phuket World actually knows about perspective, and he knows that we would spot this immediately. What's more, this observation by Davis and Baldicats disproves the flat Earth, because it's impossible for that far battery to appear lower than the near two. So basically, Phuket Word pulled a shell game trick on you. I want you to watch him do it. See what he does. Remember, the hand is quicker than the eye. He's very practiced at this. I suspect that he probably plays 3-card Monte. Watch it again and pay attention to the back lighter. We'll slow it down a little bit for you. So in his effort to debunk this rather good scientific observation, Phuket had to resort to this trickery. Notice the distraction of the book. Now, he switches hands. He's holding it in his left hand. He reaches over with his right hand, flicks the lighter, and using his hand as a screen, puts the second lighter up to set up this shot.
Don't worry about the numbers. Don't worry about the mathematics. Worry about the reality, about what we see. This versus this. Okay? It's very, very simple. And it's science. Thank you very much.